Hi, my name is Antonio Gonzalez. Some of you might know me as Bob. Today I'll be discussing kinetic energy in boxing, more importantly, the kinetic energy behind a boxer's punch. First off, what is kinetic energy? Basically, it's any object that has a motion in a horizontal or vertical direction. I'll get into more specifically what it is in another slide. So if you recall, at the beginning of the semester, we did this activity with the skater. We said this was the start point. He had all gravitational energy here. As he went down, it converted into kinetic energy, and at this bottom point, all the energy was kinetic. So in boxing, it's always important to have proper body mechanics, whether it be throwing a punch or avoiding punches. Obviously, no boxer goes in there, excited to get knocked out or anything. When they have their hands up and guarding, um, or whatever their starting position is, there's different stances, of course. Um, their fists have energy from their muscles and other bodily functions waiting to be transferred into kinetic energy. When a boxer starts to move his shoulders or his arms or his fist, that's the moment that energy is changing forms into kinetic energy. So up here I have the kinetic energy formula, which is K of E equals 1/2 mass times velocity squared. Uh, this is measured in joules. I have the gravitational energy formula down here, but that's just to tie in with an example later on. Um, and that's measured in joules as well. So after doing some research, that I found that the average person punches at about 5 meters a second. That's how fast fist travels. And the mass, we get that by adding the weight of your arm, your fist, and boxing glove. Well, what they used in the study that I had found. So you just plug everything into the equation: 1/2 times 3 kilograms times 5 meters a second squared, and that'll give you 37.5 kilograms meters a second, or 37.5 joules. And this is just for the average Joe, your average person. That's about how fast you punch with no prior martial arts experience. As a first example, this is a middleweight champion, Gennady Golovkin, or Triple G. Um, he usually comes into fight night weighing about 167 pounds or 75.5 kilograms. I found upon doing more research that professional fighters could use up to 10% of their body weight, um, and convert that into kinetic energy. Also, professional fighters can punch a lot faster than your average Joe. So I just said 9 meters a second, which is 4 meters a second more than the average Joe. I plugged that into equation, the kinetic energy equation. So same thing. Then I got 308 joules. So 308 joules, that's a professional uh, fighter, minus the 37.5 joules of the average Joe, gives us 270.5 joules more. And that, just to put that into perspective, here I'll show you on the next slide. So we can also generate the same amount of energy, gravitational, by dropping a 15-pound sledgehammer from a height of 4.5 meters. That gives us 300 joules, which is roughly the same amount of energy as the punch thrown in the previous example. So just quickly, the mass does matter. Obviously, the bigger mass, take 10% of it. Same speed, we have 413 joules, which is 105 more joules than the middleweight, 308 joules. Here's an example of a smaller fighter, Manny Pacquiao. Comes into fight night weighing about 63.5. Take 10% of that again. Except he has a faster hand speed. His fists move a lot faster than most of his opponents. So instead of 9 meters a second, I made it 10 meters a second, which gave me 318 joules. More energy than the middleweight, which weighs 20 more pounds. Kinetic linking is basically the way your entire body moves together to generate power, or kinetic energy, I mean. But I'll let the video explain more of that.
Data from the dummy combined with motion capture of Steve's punch, provides an inside view of devastation. When Steve's 1,000-pound punch lands, it sends the brain sliding inside the skull. A chain reaction occurs. The skull accelerates and decelerates rapidly, but the brain, floating in cerebrospinal fluid, keeps moving. The brain recoils toward the back of the head, causing trauma from the rear. It then snaps to the front of the skull, multiplying the damage. Trauma from both sides. Neurotransmitters fire. An electrical storm short-circuits the nerves. Doctors call it a severe concussion. We call it a knockout. Technology confirms legend. The one-punch knockout is real. But how do they do it? The secret of boxing is known as kinetic linking, a perfect flow of energy through the entire body. Motion capture shows that the punch starts not in the fist, but the feet. The rear foot drives backwards into the ground. Like links in a chain, the energy travels up the leg, twists through the hips, and into the large muscles of the back, chest, and shoulders. Like the coiling and cracking of a whip, the energy multiplies through leverage as it flows through the body, travels out the arm and fist, and snaps into the opponent. And yes, size does matter. The bigger the puncher, the more mass in the whiplash.